Marginal analysis. Within the context of economics, when thinking about cost, revenue, and profit, one of the ways in which we analyze what's happening is by using what's called marginal analysis. The word margin means that we are considering what's happening on the margins or at the margins. And the way we do this is by considering each of these functions at the margin, which means adding one additional quantity item and seeing what impact it has on the dependent function. So for cost, we're talking about what would be the cost of manufacturing one additional item. For revenue, what is the additional revenue we get from selling one additional item? And profit, the marginal profit, is what is the additional profit we would make from making and selling one additional item. Fortunately, because of the things we've been looking at, we've been considering the linear cases. And with linear cases, we know that the slope tells us how much a function will change in the dependent direction for every 1 unit we move in the independent direction. So whenever your function is linear, the marginal cost, revenue, or profit is just the slope of the line. But we need to remember as we think about that, that's telling us the additional cost, revenue, or profit from making, selling, or making and selling one more item. So this idea of moving 1 unit in the independent direction is really important, that one additional item. So this typically comes up in context with other questions about cost, revenue, and profit. So let's take a look at an example and just see what the wording would look like when we want to talk about what's happening on the margins. The cost of a particular item is given by C of Q equals 8,100 plus 4.45Q. And the revenue is given by R of Q equals 5.65Q. Part A. What is the fixed cost of this product? So if we want to talk about fixed cost, we want to start by going to the cost function to figure this out. So our cost function is C of Q, and the fixed cost is the cost when quantity equals 0. So the cost even if you have not produced any items. So if we let Q be 0, then the second term would zero out, which means that our fixed cost is going to be the cost that's left over, which is $8,100. Remember, the units of all of these cost, revenue, and profit questions is going to be in dollars. So $8,100 is our fixed cost. Part B says, what is the marginal cost per item? So remember, the marginal cost is the cost if we were to produce one more item. How much more would it cost us? And we said when that's linear, that's represented by the slope. So here, my marginal cost, also known as variable cost, is $4.45. So again, it's the slope, it's the number associated with Q. It's also called the variable cost, but we can also talk about it as what's on the margins. Part C, what is the price this item is sold for, and what is this called? So when we're selling the item, we're now talking about the revenue function. Remember, revenue is what we get for selling the item. Since revenue is price times quantity, we are looking for price. So we're looking for the number that multiplies quantity. So that is $5.65. So this $5.65 is the price that we are charging for this. It is also called the marginal revenue because it's the slope of the line and it's the amount of additional revenue we would get if we sold one more item. Part D. What is the profit when quantity equals 1,000? So if we want to talk about the profit, we want to set up the profit function. So remember, profit is revenue minus cost. So if we plug in our revenue function here, we get 5.65Q minus cost. When we subtract off cost, we have to subtract off the entire function, so make sure you're using parentheses. And so if we simplify this, we can combine the two terms that are the same that have the Q, 5.65Q, and then it's going to be minus 4.45Q. That minus goes to both terms. So when we subtract that, we get 1.2Q, and then we have a minus 8,100. So that's our profit function, 1.2Q minus 8,100. So if we want to know the profit when Q equals 1,000, we're going to plug in 1,000 in for Q here. So 1.2 times 1,000 minus 8,100 to get the corresponding profit. It turns out that when you plug this in, and I write this over here, you get negative $6,900. So the profit here is a loss, right? So when we talk about profit, it could be something that's profitable, which means you have positive profit, or it could be a loss, which means you still are in the hole more money than you've made. So our profit here is negative $6,900. Part E, what level of production does this company need to reach to make a positive profit? So we noticed before that our profit was negative at 1,000. So we know that we're going to need to make and sell more than that, most likely, to get into a positive space. So what we're really looking for here is the break-even point. If we can figure out when we break even, then we can figure out when we're going to be positive, which is exactly 1 unit more than the break-even point. So to find the break-even point, we want to set our profit function equal to 0. So we take our 1.2Q minus 8,100, that's our profit function, and set it equal to 0. Let's bring the 8,100 over. So we have 1.2Q equals 8,100. Divide both sides by 1.2, and we're going to get 6,750. So remember, that's the amount that we would need to make and sell of this product in order to break even, which is when the profit is 0. So in order to make a positive profit, we're going to need to sell 1 more than that, right? So the first time that we're actually going to be positive is 6,751. So the break-even point is when the profit is 0, and the positive profit starts at 1 unit more than that. So that's going to be our positive profit here. And then for part F, it says when this company produces and sells 1 additional item, what is the marginal profit? So when we're on the margins, we're looking at the additional profit from making and selling 1 more item. There's 2 ways we can do this. Since we already have the profit function, we can look at the slope of the line. So the slope here, the rate of change, is 1.2. So that means that if I make and sell 1 more item, I will make an additional $1.20 of profit. If I didn't already have my function for profit, what I could do is look at the marginal revenue, right? So I'm going to write MR for marginal revenue here, which we said was $5.65. I could look at my marginal cost, which was $4.45, and I could look at the difference because the additional revenue that I take in minus the additional cost that I take in from making 1 more item also tells me the additional profit. 5.65 minus 4.45 also gives us this 1.2, which is $1.20. So if we didn't already have the profit function, we could use marginal revenue and marginal cost to determine this. So now let's talk about the depreciation function. So a depreciation formula is going to give you the value in dollars of some item as a function of the number of years T since the item was purchased. So we're thinking about the value of something. There are certain items that go up in value over time and others that go down in value. One that we usually talk about is cars. Unless you're talking about classic cars, cars typically depreciate in value over time. So you may buy a car for $20,000, but in 10 years it's only worth $4,000. So that is something that has depreciated. So for now, we're going to assume that the value of an item depreciates linearly. So if we know the value at one point in time and the value at another point in time, what we can do is we can come up with a function, v of t, so we can figure out the value of the item at any time. Let's look at an example. Suppose that the ceramic pineapple manufacturer has a machine that costs $16,000 and is sold 10 years later for $4,000. We say the value of the machine depreciates from $16,000 today to a resale value of $4,000 in 10 years. Find the linear function v of t that represents the depreciation of this machine. So what we really have here are two data points. When time equals 0, which is today, the value is $16,000. When time equals 4, so 4 years from now, the value is $4,000. So we can write these as points if we wanted to. So 0, 16,000, 4, 4,000. So if we're looking for a linear function that models these 2 points, we're going to use what we know about lines. We're going to look for the slope of the line and the intercept. So over here on the side, let's talk about the slope. The slope is the change in y over the change in x, or the change in the dependent variable over the change in the independent variable. So here, that'll be 16,000 minus 4,000 over 0 minus 4. So 16,000 minus 4,000 is 12,000 divided by negative 4 gives me a slope of negative 3,000. So I come over here, and that's my m. I'm going to use the variable t here because I've been using t all along, and it's v of t. And so I have my linear term, but I need to think about the intercept. So the intercept is the value of the dependent variable when the independent variable equals 0. Well, we already have that value. It's 16,000. So I have plus 16,000. So here I have the value of this machine at any point in time. If I plug in a 0, I get the value is 16,000. If I plug in a 4, I get the value is now 4,000. But I could also plug in any number in between to get the value at any point in time. So that's how we determine the depreciation function for an item if that function is linear.